So my name is Nick Manoogian. I'm a software engineer at Doppler, and I'm going to be talking today about SecretOps. I'm going to dive in, not talking about SecretOps, but about applications. So every app has three parts. It's got your code, which is your application logic, right? Everybody likes the code. You got compute, which is where the code actually runs. Usually this is like a VM or some serverless platform someplace. And then you've also got your secrets. And secrets are the configuration that your app needs to run. These could be sensitive values like API keys for third-party services. It could be encryption keys like an SSL certificate or private key, or it could be just configuration, non-sensitive port numbers, log levels, things like that. All of these things are required to run your app. And I want you to take a minute to think about how your org deals with workflow around each of these components. For code, we've got really mature processes as an industry for managing changes to our code, right? We've got like at the base layer, Git, right? That's tracking absolutely everything. You've got the whole repository is just a series of diffs stacked on top of each other, right? Then you've got a layer on top of that, which is something like a GitHub or a GitLab, which allows your developers to submit changes for review. And then a layer on top of that, which is CI/CD, that actually makes sure that the code is acceptable and actually facilitates shipping it, right? Which is pretty amazing in multiple environments most of the time, staging and production or wherever you're going, right? So we've got really mature processes around our code. And then on the compute side, it's a little bit newer, but we've got similarly mature processes for managing our compute. We've got systems like Terraform and Pulumi that allow us to manage our infrastructure as code with similar processes, right? It's very rare that you have to like rsync your code up to a server, and it's very rare that you have to go into like the AWS dashboard and click around and make resources. We don't manage our resources that way anymore, right? But think for a minute about how your organization manages secrets. These processes are a lot less standard. Some orgs have more mature processes than others, but for the most part, it's safe to say that they're pretty scattered. And this is kind of where this idea of SecretOps comes in. It is the like CI/CD for equivalent for code or the infrastructure as code for infrastructure. SecretOps is the orchestration layer for secrets. So I work for Doppler. Doppler makes a product in this space. My goal is not to sell you on Doppler, but it is to sell you on the idea of SecretOps. And there's a couple of layers to it that we're going to go through in the course of this talk. And they're not really like features or boxes to be checked. They're sections or categories in which features would fit. And your organization is doing some form of this as it stands, right? But like you necessarily, if you're operating an app, it's got configuration, and you're necessarily using some kind of secret. So it's helpful just to contextualize each of these layers as a place where you can be doing work, right? Or a place that may or may not need improvement. So without further ado, let's dive in to the first layer, which is secret storage. And I'll start with the story. When I was fresh out of school, I got my first engineering job, and I got my laptop, and I cloned the repo. It was a Python app, and I went to go spin up the server, right? I did Python app.py, enter, right? And I immediately got an error, right? The Google _maps _ API key is missing, right? So I talked to my manager. I'm like, hey, I got this error. I said, oh, you need to go talk to Steve, right? I'm like, oh, okay. So I ping Steve, and after a few minutes, he comes back to me, and he's like, oh, you need this .env file. So he gives me the .env file. Right. And immediately there's some questions that are going through my head. Like, are these like your secrets that I have to change? Like, do I have to update any of the values in here? And like, how do I, like, if my first assignment was to add something related to email, so I was going to add the SendGrid API key, right? Do I just, when the time is right, I'll just add that in? Do I need to like drop in Slack, like, hey, everyone, here's the SendGrid API key. Make sure you add it to your .env file. That aside, like, how does this work in staging and production, right? Like, who do I need to talk to get this secret landed in staging and production? And are there any processes that would prevent me from accidentally shipping code that requires a secret that I haven't submitted? And I hope that the answers to these questions aren't like submit a ticket with the ops team, right? So The point of secret storage is not just to like make sure that secrets are stored securely, because that's table stakes, right? Like I would hope that everyone has a secure place to put their secure secrets. The challenge is it one place, and do your developers know where that one place is, right? How do I get the secrets to run my app? How do I add a secret? And this all ties into this idea of sprawl, right? We're talking about the local development scenario with Steve, right, and the .env file, but in staging and production, if you're running a more complicated app, it's unlikely that your secrets are only consumed in one place, right? Maybe you're running, some server that is going to need to consume secrets from AWS Secret Manager. So that's where some of your staging and production secrets live. And then, you've also got a front end that's got some edge stuff associated with it. And those secrets are in something like a Vercel, right? It becomes really hard to get a handle on where your secrets actually live, which services actually consume them, what work needs to be done to add new ones. It's a bit of a mess. So the first thing to do is to centralize all of this information. So I promise not to sell you on Doppler, but I do have to show you some screenshots to show you what these things look like. So with that disclaimer out of the way, this is how we do it in Doppler. So here we're looking at a project in Doppler. We've got the backend project, and we're in the local environment or dev config, and we've got some secrets, right? Like our database password is a secret. We want to keep our user and host secret. That's arguable. But then there are some completely non-secrets, right? We call those unmasked values, like the port number and the log level. So that's great. If I had this when I was starting out as an engineer, I would add a SendGrid API key. I gave this dry run talk to somebody, and they were like, you better call out that that's not a real API key. So I'm doing that now. That's a random hex string. You can try it against the SendGrid API if you want. It won't work. But with that out of the way, so I would have added this API key, and I would have hit save. And when I go back up and look at my higher order environments, I get a warning that the assumption is made that you should have those secrets in all of your environments. And you get a warning saying, hey, this secret is missing from this environment. So that's the kind of benefit that you get from centralization, right? So you've got one source of truth, one place where all of your secrets live, and your developers know that. Your developers know, like, I know exactly where I need to go to manage my secrets. Once you've got secure storage out of the way, everything is together. The obvious next question is, who has access to these secrets? And that's kind of for each team to decide. At Doppler, no engineers have access to production. That's how we like it, right? There are trade-offs to that, but nobody on the engineering team or like effectively the operations team has access to production. All requests have to go through a very select number of individuals. But regardless of what your policies are, your tool should be able to build those policies in. And that absolutely means setting up automation. So you should have some construct like roles and groups so that you can easily say when an engineer joins, they should be in this group. You should be able to hopefully automatically put people into those groups with tools like SAML and SCIM, so that when you're scaling, you don't need to tell every engineer to go to Steve, right? That's the benefit. And then when you're offboarding, a team member leaves the team, you know exactly that they're going to lose access to all the secrets that are in that one place. This isn't possible if there's 20 places that you need to manage secrets, right? You'd have to go set up 20 automations. But when you've got everything together, you can add the access control layer. The other piece of this is tracking. Sort of going back to this idea of we store all of our code in Git. Like, I can't imagine going back to a world where like I didn't know what code had changed, right? So that's absolutely a layer of this, is being able to see what the changes were over time. So this is, again, what it looks like in Doppler. I make a change, that change is tracked, it's time-stamped, and you should be able to roll back to any version. So if something breaks in production, you've got a clear indication of what changed. So you've got everything stored in the same place. It's all locked down. Steve and I had this figured out, right? Like in staging and production, after I was working there for a little while, we just put everything in one password, right? All of our production secrets were in one password. And to actually get them into production or staging, Steve would go into one password and copy the value, like that was our source of truth. And then he'd SSH into the production machines, and he'd copy that value into secrets.json. Their processes have since matured, but that was what it was for a time. So that is the orchestration piece, right? Like that was our version of orchestration, delivering the secret to the compute instance that actually needs to consume it. That's not a good way to do it, right? If Steve forgets to copy that value, we're in trouble. So a better way to do that is you've got your source of truth, you've got something like Doppler. Let's set up some automation to sync those secrets where they need to be. And it shouldn't be a process where a tool asks you to completely overhaul how you consume secrets, and it takes you months to embed this tool everywhere. We're kind of the opinion that a tool like this should meet you where you are, and that typically involves syncing secrets to where they need to go. And what that actually concretely looks like is you put your secrets in a tool like Doppler, and then you set up automations where those secrets are synced to where you need them. And those places are going to be different depending on the environment and the context of what the code actually does. Maybe in local development, maybe your developers are, building a server. The CLI should inject those secrets into your app running locally, right? That's probably the easiest way your developer is going to have access. In staging and production, maybe the easiest way for you to consume secrets is through AWS Secret Manager. Like that might be the easiest way, in which case let's just sync the secrets to that place. Nobody needs access to those except the compute instances that need to consume from them. But if that's the easiest place, and it's, it meets your high availability requirements and it meets your cost requirements, why would you change that, right? So get the secrets to where you need them. And the way that we achieve this is with integrations. We try to implement as many as we can, but that's something to be looking for, is how easy is it to actually deliver the secret into your production environments. And the other piece of this, which is really handy, and an area where we're continually investing in, is automatic redeployment. So we support this right now, specifically in Kubernetes, where if you set up the operator, our Doppler operator, we can sync secrets into a native secret in your cluster. So it's available for you to mount as a file or to inject as environment variables, which is handy. But after that operator completes the sync from Doppler into a native secret, it can go identify all the workloads that are relying on that secret and restart them. So end to end, what this looks like is the developers that have access to the production environment can make a change, and with one click, deploy that change, right? That a few slides back, we updated the warn to info for our log level. As soon as I click that button, my apps will restart with whatever processes I have in place for health checks, and they'll come back up with that log level. That is really what we think is the holy grail, right, of orchestration, right? You've set up a CI system for your configuration. Once you have orchestration in place, I think I just have this graphic to show how we think of it at Doppler. It's sort of like a hub and spoke. We're trying to set up syncs with as many integration sources as we can, because we want to meet developers where they are. So that's something to be looking for, is the number of integrations that a tool like this has. Once you've set up storage and governance and orchestration, it becomes really much easier to manually rotate secrets, right? Folks generally know that rotating secrets is a good idea. You want to reduce the surface area of your secrets. In the roundtable, we were talking about long-lived keys that were generated on a developer's laptop years ago. That's not a good story, right? You don't want to have long-lived secrets. So Steve and I, we knew we had to rotate secrets, but this is kind of where we stopped in the SecretOps process, because we just didn't have a really good handle on all of the apps that were consuming the secrets that we would want to rotate. Like when the time came to rotate that SendGrid secret, we just weren't sure which workloads were consuming it. And we didn't have the confidence that if we updated the value in all the places that we knew about, that we would actually get everything. So we had to kind of pick between putting ourselves in an insecure position by not rotating, or putting ourselves in a risky situation from an uptime perspective, because rotating, it might mean we bring down our apps. So that's not a good situation to be in. Once you've got confidence that your secrets are being used in the places that you know about, and that you've got the appropriate orchestration to deliver those secrets to those stores, just going into the SendGrid API or the SendGrid dashboard, generating a new key and plopping it in Doppler is enough to give you the confidence that rotation is going to work, right? If you've got that end-to-end set up, and you know that updating the secret in the Doppler dashboard is going to trigger redeployments and get your apps restarted, then it becomes way easier just to do that. But you can actually take it a step further. If you've got the confidence that changing values in your Doppler environments will actually propagate, you can set up automated rotation. So this is, again, something we're continually investing in. But in this example, instead of generating an API key for SendGrid and just dropping it in my environment, I've actually set up a rotation policy so that this API key gets rotated every 30 days. So after I created it and I set up the policy for what I want this API key to be able to do, the secret values, they live alongside the static values in my config. And they're rotated so they can't be modified. They're sort of managed by the Doppler engine, which is pretty handy. But what's also really cool about this, and you'll notice that all these masked values here are hidden behind like a obfuscation. There's like the 6 dots there. They're not actually 6 characters long, but the underlying values aren't actually in the DOM here. They require an API hit on our servers to actually download, which means that until someone intentionally clicks that SendGrid_secret value, that secret has never been seen by a human, which is really, really cool. That's kind of really what you want. That secret has never been in a developer's clipboard. It's never been seen by human eyes. And that's really what we think is super valuable. If you've got the confidence to be able to rotate on a cadence like this, it becomes really, really easy to set up this kind of automation. So that's managing the secrets lifecycle. And the last sort of piece that sort of ties all this all up, and this really wasn't even on Steve and I's radar, to be honest with you, is effectively tracking the who has seen a secret. It kind of goes back to that, have any human eyes ever seen the secret before? That's an interesting question to ask, right? Every time you download a secret or a secret is transmitted onto a server and is used, it's a risk of a leak, right? That's an opportunity for that secret to end up in the logging system in an HTTP log, or it's an opportunity for it to get squirreled away onto a bug tracker if it's embedded in like the auth headers of an error. Those are all opportunities for a leak to happen. And if you want to answer the question, like, the secret was leaked, where was it leaked from? It's pretty difficult to answer that question unless you've got some sort of observability in fetching. So observability is about asking the question, who has seen this secret? And sort of on the converse of that question is, what are all the secrets that this person has seen, right? If you're offboarding someone, if they've seen the secret, they can take it with them, right? They could easily have copied some value and now they've got that. And there's tons of, SaaS products that don't have any kind of protection, right? Like if an employee saw your Stripe API key and they take that with them, they can make requests against your Stripe API. So being able to ask the question, which secrets has this person seen is a really tricky one to answer. So this is, again, an area that we're investing in, but the functionality as it exists in Doppler right now is, as I mentioned, secrets aren't read until you actually click into them. So here I've actually clicked into reveal this value for the password field, again, random hex. And it's I can open this view and see for the current version of the secret, all of the actors that have seen it. So coupled with rotation, if we discover that there's a leak and we have the original value, we can, in theory, go back to this and look at the version that matches that value and see every actor, service or user that has ever seen that secret. And if we're rotating on a cadence like every 30 days, that list might be really small. So being able to plug leaks like this is just not really something that most teams can do right now. So this is still pretty rudimentary, and we're making big investments in this right now. It's something that we're really, really excited about. So those are sort of the layers as they exist right now, the sort of overarching ideology. I wanted to take a couple of minutes to talk a little bit about what's on the horizon, things that we're really excited about. So identity auth it came up in the roundtable. We're in the secrets business, but portable credentials are really not the best way to be operating. Open standards like OIDC allow workloads to authenticate to other services without a portable credential, right? Anytime that a developer is accessing secrets in Doppler over the wire, they're doing so with a portable credential, with like a API key. So we're really excited to see the elimination of some of those things. And in the gaps that we can't do identity auth, doing heavy rotation. and then putting that behind identity auth through Doppler. This eliminates this idea, the zeroth secret. That is the zeroth secret is that the Doppler API key that gets you in the door so that you can fetch your other secrets. There will always be that zeroth secret. Not so if you're using identity auth. And the second piece to this, which is somewhat related, is dynamic secrets, which you could imagine as like really fast rotation, I guess. Imagine that your workload, when it fires up, instead of having a list of rotated secrets that it can use for a period of time, it actually requests a lease for a new a new resource. So you can imagine like a migration that you have running, or maybe a deploy job that's running in CI. You would need some secrets to like interface with AWS, for example, to deploy the code to where it needs to be, right? We have this feature right now, it's in beta. The one we currently support is AWS IAM users. So you would configure Doppler to say, whenever a workload requests this environment, issue them a brand new AWS IAM user with this policy, and make sure that it does not live for more than 30 minutes or until the service itself requests its revocation. So when the CI job is running, it hits Doppler and asks for all the secrets, and it issues all of these resources, and some of them are these dynamic secrets, and that actually creates a brand new AWS IAM user, applies the policy, and generates a key all in one shot, and then returns that out to the user, or out to the workload. Once that work is done, it can revoke it at the end, or if it, that job fails or whatever, it gets cleaned up automatically. What's amazing about this is that credential only lived for that small period of time. So if you find that credential is leaked, you can trace it back to like this one 30-minute window, right? That it must have happened in, because nothing else has ever seen that credential. No, it's not shared across any other actors. It's so isolated. And if you're only running a deployment like every couple of days or every week or something like that, there's just no need to have a loose credential hanging around. If it's only needed for a short window, why wouldn't you just make that resource when you need it? So this idea of like limiting access to third-party data is what this is really about. That's what's kind of up next for us on the horizon, stuff that we're particularly excited about. And I'm coming in a little under time. This is mostly what I had to talk about. So I wanted to open up to any questions y'all have. Yeah, thanks so much for listening.